Here's these, and then anything else?
Okay, write down that word in your notebook, please. Write it down. This is Unit 5. Okay, we're at the point in the year now, listen, where we will no longer have standalone units. So we will learn some new concepts, and then you'll take a test. The AP test is broken up into 4 sections. The first section is no calculator, multiple choice, 30 questions. The second section is with your calculator, 15 questions, 45 minutes with your calculator. Then you have a break. Then you do 30 minutes with your calculator, 2 full FRQs. A full FRQ usually involves about 8 questions. Sorry, a full FRQ is about 4, so 2 of them is about 8. Then you do 4 more full FRQs, so about another 16 questions without your calculator, then the test is over. It's a bit longer than, I think the ACT is, well, including the writing section, it's about the same length as the ACT. Okay. Calculus is okay. What some people don't realize is that the AP, the College Board considers some AP classes to be simply kind of honestly half-year high school classes, even though they're often taught over a full year, and so they don't give as much credit for those. The AP Calculus test is considered to be a full-year AP test. It is still a AP test where colleges and universities still give full college credit for passing the test. So yeah, the test is a serious test. It really can grant you, honestly, credit that can count towards, I would say, about, looking at kind of how much BYU charges for tuition right now, probably about, if you get a 4 on the AP test, you're going to be earning enough college credit to satisfy about $2,000 worth of tuition. Okay, about $2,000, I'd say. So it has to be a legitimate test. It's not, they're not messing around. Anyway, this unit is not a standalone unit. So we'll learn some concepts, and the test you'll take will be not really the entire first section of the AP test, but pretty similar. So the test you'll take this next time will be multiple choice without your calculator, and it will mimic the first section of the AP test. So it will cover most of the year. There's still a few concepts we pick up as we kind of move along, but this is not a standalone unit. So in this unit we'll learn about antiderivatives and some other things, but then the test we'll prepare for covers pretty much the entire year. Question? Okay, the word antiderivative means what you would probably suspect it means. The idea is that if you have a function, and we call that function f, so I just wrote down something simple. We could write down pretty much anything. I just call this one f of x equals 3x squared. You can think of that function as being the derivative of something. Like there was some function, we took the derivative, and we ended up with that. In fact, this is what we did. let's call capital F the other function. So this is why it's important to keep capital and small f separate. Let's say capital F is the function x cubed plus 8. Well, if you take the derivative of capital F, you get small f. This is the same thing as capital F's derivative. Okay, come on. Question. Antiderivative implies the idea that we don't know what capital F was, let's go figure it out. So it's what we tend to think of as going backwards because we learned derivatives first. You could have learned antiderivatives first. It doesn't really matter that much, but we'll think of it as backwards. It's not really backwards, it's more like a circle. So, question. Okay, here's the symbol. Okay, it looks just like the integral symbol. In fact, it's the same symbol, except there are no limits attached. So when you don't see any limits, don't think integral. Think antiderivative. It can be confusing. No, I totally agree. With the limits, integration. Without the limits, anti-differentiation. They use the same symbol, though, 2 points for Kate, because they are very closely tied together. I try to eliminate the confusion that Kate just mentioned by always using the word antiderivative. If you talk to parents or friends or tutors, they may throw in some other words just to make sure that you are fully confused. Okay? So a lot of parents, a lot of other teachers, a lot of tutors will use the word integral interchangeably. Like in some contexts, they'll say integral when they mean antiderivative. In some situations, they'll say integral when they mean integral. And they just use it loosely, and you're supposed to figure out which one they're talking about. I think that's confusing, so I don't do that. If I'm talking about an antiderivative, I'll say antiderivative. If I'm talking about an integral, I will say integral to keep those separate. Questions? The other words that do show up in books and whatever on the internet, a definite integral is what I refer to as being an integral. And I'm not the only one. There's lots of math teachers who like this approach that I'm taking. An indefinite integral is what I call an antiderivative. But again, I don't like, those are easily confused, so I prefer integral, antiderivative. Questions? Somebody asked last period, what do you need to know for the AP test? I don't have any recollection of ever seeing an AP question that used these two terms. There may have been one, but extremely rare, so I don't think that's a big deal to remember those. I do remember the AP test using this term, and they do say integral sometimes, but my recollection is they always use it when they're talking about what I refer to as being an integral. So another advantage of the method I'm using is it matches up with the AP test. So, questions? Awesome. So anyway, the symbol is, as you saw, right here. Now, I've been teaching you correctly that when we do an integral, we are multiplying f times dx repeatedly, and then the big S says we add them up, we sum them up. When you see an antiderivative, you have to think of it a little differently. Don't think of it as multiplication anymore. Think of it as this symbol here that I've underlined and this symbol here are pointing to the thing in the middle, and they're telling you, hey, you need to find the antiderivative of what's in the middle. So think of these two as just the operators that point to the middle one and say, go find that antiderivative. So your brain has to think differently when it's an antiderivative. Questions? Cool. Okay. The good news is that, well, in Calc 2, they spend a lot of time, like a big part of BC calculus is learning AB first, of course, because they cover the same thing we do. But then they go on and they study antiderivatives heavily. So if you were to go to college and take Calc 2, a good portion of that class will be a study of how to take antiderivatives using many different methods. For our class, we really only learn one method, and that is there's a few rules, 5 of them. We learn how to apply those rules. That's really it. So we don't learn much about antiderivatives. It's just very short, pretty simple. We do learn, though, that sometimes the rule doesn't work. Sometimes we have to do what I call a U substitution. Textbooks sometimes refer to as integration by substitution. If you've heard this term before, it's because they use this method for a different purpose. Okay, we'll use it to find an antiderivative. But what I want you to note by the way I've written this is, you only find antiderivatives in this class using a rule. There's just no other way. You always use a rule. The only reason we do a U substitution is because sometimes we've got to rearrange the problem so that we can use the rule. So the U substitution is a rearrangement. Then we use the rule. Sometimes we just do a little kind of algebra trick, and then we use a rule. But we're still just using the rule. Question? Please, Nate.
So the algebra also rearranges so that a rule fit.
Absolutely. So yeah, the big emphasis I wanted to make, 2 points for Nate, is that you're just using the rule. We do U substitution, we do algebra just so we can use the rule. So we don't find any antiderivatives any other way, we're just using the rule. Other questions? Cool. What I wrote here is capital F is the antiderivative of 3x squared. Okay. Rules. So you don't need to copy these down. I will post them on, if you want to copy them, you can, but you don't need to. I'll post them on my website, but here are the rules. Turn that off. Okay. So I'll post this and you can print out a copy from the website if you like. We will have a quiz on Wednesday to make sure you have memorized the rules. Okay?
Oh, awesome.
Now look at me, look at me, look at me, look at me, look at me. There are 10 boxes on the board. Okay, I'm going to show you a trick so that you can memorize 10 rules by memorizing 5. Okay? So it actually goes pretty fast if you follow the trick. So let's talk about it until you're like, hey, I see the trick, I can do that. Watch. Okay, over here, notice. Hey, notice this is x to the n. This is, don't look at anything else, just focus here. This is x to the n, e to the x, 1 over x, sine x, cosine x. Okay, just 5 rules to memorize. Okay, don't worry about anything else for a second. This column, there's only one difference. Instead of being x to a number, it's ax plus b to a number. A is just some constant. So this is x to a number, like x to the 5th. This is like 3x plus 4 to the 5th. The only difference is it's x alone. Sorry. Here it's ax plus b. Hey, this one, same thing, look. Same thing. E to the x, the other column is e to the ax plus b. This one is 1 over x, the other column is 1 over ax plus b. Sine x, sine of x plus b. Cosine x, cosine of ax plus b. Anyone need me to talk about that pattern so far? Okay, so in my brain, I'm not memorizing both rules. I'm memorizing the short rule, and I'm remembering that x can be replaced with ax plus b to make the memorization quicker and easier. Next thing, I do have to memorize the short rule. The antiderivative of x to the n is x to the n plus 1 divided by the same, plus a constant. It's always plus c. So there's a typo here. This should have said plus c. I'll fix that before I post it. This should have said plus c. There's always a constant. Here's why. Look back here. When you take a derivative, if there's an additive constant by itself, that the derivative process causes this to become 0. So we're going backwards. We have to consider that we could have been adding something other than 0. That's why this has to be plus some unknown value. Please.
So will we just be using 0 as we
We just put plus c.
Oh, okay.
It's just to remind the grader, there's like, hey, I understand that maybe it's plus 5, maybe it's plus 6, maybe it's plus 0. I just don't know. And then eventually we'll learn how to find out what the value is if they give us some other information. Please.
Right. So to me, that looks kind of like almost like a graph equation. You know how the y-intercept is a plus then a constant? Is that similar?
It's similar, it's not exactly that, so don't think of it as the y-intercept,
Okay.
but it is that same kind of visual idea. Yeah, for sure. It's not necessarily the y-intercept though. Sometimes it is, sometimes it isn't. Anybody else? Okay, cool. 2 points for dinner. Look, so the rule is x to the n, and then x to the n plus 1 over n plus 1. Okay, the larger rule is easy to memorize because the x simply gets replaced with ax plus b. In the rule, the x just gets replaced with ax plus b. Wherever there was an x, I just replace it with ax plus b. The only additional factor I must include is this 1 over a multiplier. That's it. So if I memorize this, and I remember the ax plus b trick, I've already memorized this. I'm not memorizing 2 things. I'm memorizing one thing with a trick to get the second. You want me to say it again? Just wave at me. Okay, look at this one. The antiderivative of e to the x is just e to the x. Plus a constant. The plus c is there always, so that's easy to remember because it's always there. When I go from here to here, I replace the x with ax plus b. Same thing here, add the 1 over a multiplier. That's it. If you prefer, think of it as you always divide by a. It doesn't have to be 1 over, you can just think of it as dividing by a if you like. I think it's easier to write 1 over a. But. Question? So Wednesday we'll have a fast quiz to verify that you have memorized this. Okay? So it's simple. 10 boxes, 10 points. So. We need help with the trick. You know, I'll post that on the website, so you don't have to copy it down by hand. That's a little tedious. Picture's good. Sure. Yeah. Okay, a couple of quick examples. You good? All right. So a couple of quick examples. Just a second, let me reset the Zoom on this. Don't get dizzy. Okay, so here's what we're going to start practicing for a couple of days. You see this? Number 1. Put this in your notes, please. Okay, it says, what is the way you read that is you read the antiderivative of e to the x is, well, I think of the rule. The antiderivative of e to the x is just e to the x. Plus c. That's it. If you want to check if you've done it correctly, you just do it backwards. You say, okay, let's do the check here. So if I were to take the derivative of e to the x plus a constant, the first rule I would use is the additive rule. The derivative of a constant alone is 0. The derivative of e to the x is just e to the x. So you're just doing a circle. You now can do a circle. You can say, hey, start with a function, find its antiderivative, take the derivative of that function right back where you started. Okay? And it's a circle. You can start here, take the derivative, then do the antiderivative, you're back where you started.
Hang on, it's just been a while. With the additive rule, don't you take out the constant? That was 0, right?
Yeah, so the details here would be this. You'd say this is d of e to the x over dx plus d of a constant over dx. That's equal to 0. Derivative of e to the x is just e to the x dx dx. So that would be the details. Please.
I'm sorry if this is already been answered, but in what context do you use antiderivative? Why?
Gotcha.
Where do you use it?
So where it fits is the idea that when we started, hey, 2 for paint, 2 for David. Okay, now this is a really simplified example, but the idea is that we started the year talking about the fact that we could have an equation for the position of a particle, and if we wanted to know the rate at which that position changes, the velocity, we use differentiations. We take a derivative, right? Well, if we want to go back and find an equation for this, we're going to use the fundamental theorem of calculus, really. But if we don't have a calculator, we have to know how to do antiderivatives to make that work. So this is primarily for the non-calculator section of the test, how to handle this antiderivative. So does that answer your question? Cool. Anybody else? Awesome. Here's another quick example. If we had e to the 3x, and we're trying to find the antiderivative, that's e to the ax plus b. The a is 3, the b is 0. Wait with me if you need me to explain that again. So think of this as being e raised to the 3x plus 0. So that's an ax plus b. The a is 3, the b is 0. The rule says e to the ax plus b. Wait, if you need to say it again. Okay, so now I use the longer rule, which says the antiderivative of e to the ax plus b is 1 over a multiplied by e to the ax plus b plus a constant. I don't have to write the plus 0, so I typically write this. That would be the antiderivative. Like I said to Peyton, if this had been the formula for the velocity of the particle, this is now the formula for finding the position. Although it's not super helpful yet because I don't know what number goes there. We use the fundamental theorem to find that. So.
I thought we did know that it was 0.
No, we said it's an unknown constant that could be 0. But it could be 6, or it could be 10, or it could be -3, or we don't know. That's why we refer to it as C instead of 0. This was the B value, that is 0. Please, Prince. We'll eventually get information that will allow us to find the constant, but in many cases you're not asked to find it. You're just asked to leave it as plus C. So. Anybody else? Cool. You wanted to check that? Look, here's the check. I take the derivative of e to the, 1/3, back up. So I take the derivative of this, that would be d of 1/3 e to the 3x plus c. That derivative, use the additive property, you end up with this. Okay, the 1/3 is a multiplying constant. So it comes out, you're left with d of e to the 3x over dx. The derivative of a constant is 0. E to the something, its derivative is e to the something, derivative of that something. Sorry, going a little fast. The derivative, that's just 3. 3 times 1/3 is 1. So it works. It worked. What is on Wednesday?
Wow, I've been having those.
Yeah, I kind of went fast.
Memorize